Hey everyone, Mike from CodeSpectre, and I am finally back after a long hiatus. As I get back into the swing of things, I'm going to pick up where I left off with my TypeScript data structures series. I'm also planning some new design patterns videos for TypeScript as well. If there are any other topics you'd like to see me cover, just let me know in the comments. Today, we are going to cover stacks. A stack is a pretty simple data structure where both inserts and deletes happen on the same end. To understand how a stack works, we need to first understand last in, first out, or LIFO. Last in, first out means that when you insert into a stack, it puts the data in the front of the line, so to speak. A good example would be a pack of blank CDs. In a pack of blank CDs, the first CD that goes in goes to the bottom, and then the next one goes on top of that, and on top of that, until you get to the last one, and the last one is on top. So no matter what the last CD is, that will be the first one to be taken out. Implementing a stack in TypeScript is pretty straightforward, since TypeScript arrays have built-in functions that make building stacks really easy. The two main operations of a stack are called push and pop. Push is when you put something onto the stack, and pop is when you take something off the stack. Usually pop will also return what you are popping. So if you are popping a number, that will also return the number that you're popping. Depending on the type of stack you're building, you might have other functionality, such as the size of the stack or looking at the stack in some way without popping any elements. Alright, so let's move on to our code implementation. We're going to write our stack in TypeScript with a few simple functions and some basic error handling. The functions we're writing are push and pop, which we've talked about already, but we're also going to write peek, which returns the top stack item without removing it. We're going to write size, which returns the size of the stack, and then we're going to write a function called popAll, which will empty the stack and then print out the values of the stack as it empties. Let's start by building our stack class. In our stack class, we're going to have a private attribute called data, and this will be an array of anything, or it can be null. So if you've never seen this syntax before, this basically means that this array can have anything in it. It can have strings, it can have numbers, it can have even other custom data types that you create. Let's also create our constructor. Our constructor will set data to null. So for our video, we're going to use an array to handle most of our stack operations, since JavaScript arrays provide most of the functionality that we need straight out of the box. Alright, the first function we're going to write is push. So our push function is going to take in a parameter called item, and that can be any type. And this function is not going to return anything. The first thing we're going to do is check to see if the stack is null. If the stack is null, we're going to write this.data and then create a new empty array and then put item into the array. So now item is the only thing in the array. If the stack isn't null, we're just going to use the JavaScript push method to push item onto our stack. Just like that. So it's pretty straightforward. Before we test what we've done so far, let's write our pop function. Our pop function is going to look a lot like our push function, since we're basically using JavaScript to do both operations. We're going to have a function called pop. It's not going to take in any parameters, but it is going to return type any, since we know that anything can be in our stack. So what we want to do first is check to see if the stack is null, but we also want to check if the data in the stack is greater than 0. Because if it's not, we don't want to try to pop an empty stack, because that will throw an error. So if those two things are true, we'll run this.data.pop. And what this does is it will pop the value and return it. So when you pop a value off of a stack, it will remove the item from the stack completely. If we don't meet those two criteria, what we want to do is throw a new error saying that we cannot pop an empty stack. Just like that. Alright, so now we can test what we've done so far. Alright, so let's create a new stack. Let's just call it stack. And this is gonna create a new version of this stack class that we have up here. Then let's push something onto the stack. So let's push the number 55. And then let's console log stack.pop. And this should return 55 if we did everything right. It did indeed. Alright, so far we've pushed an item onto our stack and we've popped an item off our stack. But what if we want to look at the top item of our stack, but we don't want to necessarily remove it from our stack? Well, this is where peek will come into play. Our peek function is essentially going to do the same thing that our pop function does, except it's not going to actually remove the item from our stack. We just want to look at that item. We don't want to take it off. So let's do the exact same thing that we did in our first one. We're going to check if the data is null, and we're going to make sure that the length is greater than 0. The reason for this is that we're actually going to be accessing the array like this, and then we're going to go this.data.length minus 1. And this should give us the array index of the top item in the stack. So let's try it. Let's use peek here instead. And then let's push another item onto our stack. Let's say 56. And then do one more peek and see if we get what we expect. Awesome. So we're getting 55. We're getting 56. Now, what happens if instead of that, we pop this and then peek one more time? Let's try that. We get 55 again because 56 has been removed from the stack. So peek is really useful if you want to keep track of the top item in your stack, but you don't always want to take it out of the stack. So let's add our size function next. This is basically going to get the size of our stack, which essentially is just the length of our array in this instance. So we have our size method. We have a function, size, that returns a number. And then we're going to first check to make sure that the stack is not null. Well, we're going to check to see if the stack is null, because if it is, we're going to throw an error. We're going to say can't check the size of an empty stack. Then we don't even need an if conditional because this error will be thrown. We're just going to return this.data.length. All right. So let's take out these last two things that we did. We have 55, 56, and now let's push one more thing, 57. Now let's check our stack size. Size of our stack, stack.size. Nice. So we got 3 items on our stack. If we pop our stack and then check that one more time, we should see 2. Yep, we see 2. All right, so the final function that we're going to write is pop all. Pop all is going to remove everything from our stack, and we're going to print those things out while we remove them. This isn't a common stack function. This is just kind of something that I decided to do for this, just so we could see the whole stack process. So we have a method called pop all, and it's not going to return anything, since we're just going to be printing things out while we pop them. So the first thing we're going to do is we're going to say while this.data, meaning it's not null, and this.data.length is greater than 0, making sure the stack's not empty. We're going to console log this.pop. Pretty straightforward. So this is going to loop through, pop everything off the stack, and then once the stack's empty, we're going to set it back to null so it's back in its starting state. All right, let's push a few more things on the stack. 60, 61, and 62. I don't know where I'm choosing these numbers. They're just kind of coming. All right. Let's check this out and see if this works. Stack.pop all. There we go. It's going to print out our elements in our stack from last in, first out. One of the greatest benefits of a stack is its simplicity. Since it's straightforward, it's used in a number of high-value areas like computer architecture. For example, you may have heard the term call stack when talking about an operating system. This is exactly what it sounds like. It's a stack of operations that an operating system has run. Many operating systems will use a call stack to keep track of the execution order of things that are happening. Other applications use it for the exact same purpose, and it's a very useful debugging tool when you know how to use it. Another common use case for stacks is undo operations. Many word processors and design programs like Photoshop will use stacks to manage their undos, since undoing an operation is as easy as popping it off the stack and returning to the previous example. So anytime you hit Control-Z, you may be popping a stack without knowing it. All right, before we conclude, we're going to do one final example, and this is going to be outside the stack. We're going to write a function that reverses a stack. Stacks are super easy to reverse because all it takes is to pop something off of a stack and pushing it onto a new stack, and you reverse the stack. So let's write a function here called reverse stack. And we're going to take in a parameter called s, which is a stack, and we're also going to return a stack in our function. Let's create a new stack called r. And then let's write a loop. Let's use our size function that we wrote to check if it's greater than 0. And then while it is, r.push will be s.pop. So what this is doing is it's popping the item off the stack. Since it's returning that item when it pops, we're pushing it straight on to our old stack, or into our new stack. When this operation is complete, we're returning. Let's check it out in action. So let's remove our pop all. So we know the order of our operations is, order of the number of items in our stack is 62, 61, 60, 56, and 55. So let's take a look. Let's make a new stack and set it to reverse stack, taking in our previous stack as its parameter. Now, let's take our new stack and run pop all so that we can see all the operations being popped. Excellent. So we successfully reversed our stack, and all it took is a couple lines of code. That concludes our lesson on stacks and TypeScript. It's good to be back, and I really hope some of you found this useful. If you did, feel free to like, subscribe, comment on the video. Let me know if there's anything you'd like to see me do. I'm considering starting an algorithms and TypeScript course. I feel like that would provide a lot of use alongside the data structures course. But let me know. Have a great day, everyone.